Hey everyone, welcome back to the channel. In our last video, we saw an introduction to how semiconductors are the unsung heroes powering our amazing modern world. From the phone in your pocket to the lights in your room. But to truly understand how these tiny components work, we need to speak their language, and that language is electricity. Well, in this video, we are going to learn about the fundamental elements that flow and get controlled. Think of it like understanding the water before we start building dams and pipes. We are going to break down the ABCs of electricity. Let's start from charge. We all know that tiniest building blocks of everything around you are called atoms. Inside each atom, you will find protons with a positive charge, electrons with a negative charge, and of course, neutrons with no charge. Out of these three, it's the electrons that move, and their moment creates electricity. It's as simple as that. What is electric current? When electrons start moving in one direction through a wire, that's called an electric current. Current is the flow of electric charge. Now, here's a key thing to remember: like charges repel each other, and opposite charges attract. It's just like the case in the magnets, where same poles push apart, opposite poles pull together. This fundamental attraction and repulsion is the driving force behind all electrical things. Think of current as water flowing in a river. The more water that passes through, the stronger the current. In the same way, the more electrons that flow, the higher the electric current. Now we were talking about moment of electrons, right? So for moment of anything, there is supposed to be something which leads that moment, right? Now, what makes electrons move? That's where voltage comes in. Voltage is the pressure that makes electric charges move. Without voltage, there is no flow. Let me tell you similarities of water pump and batteries. Just as the pump creates a pressure difference pushing the water through the pipes, similarly, a battery creates a voltage difference between its terminals. This difference in electrical potential is what motivates the electrons to move, eventually creating current. So till now we are clear with the basics, right? Let's revise the basics. We all know that charge is the tiny particle that moves. Number 2, current is the flow of these charges. Number 3, voltage is the push that makes them move. Just as we know that water system needs good pipes and valves to control flow, similarly electric systems need something too, and that's where semiconductors come in. I hope you can relate both now. In electrical systems, semiconductors act as a valve to control the flow of current. But wait, why do we need to control electricity? Well, think about your smartphone. It doesn't need full power all the time. It needs smart control. That's where semiconductors step in. Let me tell you an interesting fact. The human body also uses electrical signals for everything from muscle movement to brain activity, though at very low voltages and currents. Understanding charge, current, voltage is just the beginning. In the next video, we'll meet the superhero of modern electronics, the semiconductors, and we will see how it became the brain of all our devices. Have you ever thought, why do some materials allow this flow of electricity so easily while others block it almost entirely? And where do our amazing semiconductors fit into this picture? Well, stay tuned for the next video. Thank you so much for giving your valuable time for the video. Hit that like button if you learned something new, subscribe to join the journey into the microscopic world of electronics, and don't miss our next episode.